Hi, my name is Connor Redmond, and this presentation is a high-level introduction to the MyBatis persistence framework. This presentation will be of interest to you if you are a Java developer, writing applications that access a relation database, and think that the current approaches using JPA and JDBC are too complicated. In this presentation, we'll provide a brief introduction to MyBatis, and demonstrate how to build and use a simple DAO using MyBatis. MyBatis is a persistence framework for Java. It works on top of JDBC, but eliminates most of the complexity and boilerplate of using JDBC directly. It works by mapping Java methods to SQL statements. If you provide a correctly annotated DAO mapper interface, MyBatis will use that to build an implementation that can execute SQL. We'll see an example of how this works in the next slide. The MyBatis starter Maven dependency for Springboot includes an auto-configuration component. At application startup time, the auto-configuration will scan for a data source to work with. It will also scan for Java interfaces that include the MyBatis @mapper annotation and register those interfaces with MyBatis. For each eligible interface it finds, it will build an implementation of that interface and register it as a Spring Bean in the Spring context. In your application code, you can inject these MyBatis mapper beans and call the methods. Calling the findAll method on the generated book mapper bean, for example, will cause the select star from book SQL that was inside the @select annotation to be executed against the database. Finally, the bookmapper bean will attempt to map the results from the SQL query into book objects that are returned to the caller. In the SQL snippet shown here, the database column uname has an alias username in the results. MyBatis reuses this alias feature to perform the mapping of results from database columns to fields and Java objects. So when mapping the results of a SQL query into a Java object, the ID column maps to the ID field, the uname column maps to the username field, and the lname column maps to the last name field. In the following demo, we will use MyBatis to build a DAO. We will create our DAO inside a Springboot application that connects to a H2 embedded in-memory database. There is a link here if you want to download the code from GitHub and try it yourself. This demo is based on a Springboot application with a Maven build file. And so the first thing we'll need to do is to add the MyBatis Springbooter starter dependency for MyBatis. And that's it there. Next, we'll define some database tables we'll use in this demo. And here are the 3 tables we'll be using. And in this file, we'll populate those tables with some sample data. In the application.properties file, we've set up the properties needed to build a data source that defines our connection to a database server. In this case, we're using an embedded H2 database. By embedded, I mean that the database server is embedded in the Springboot application, and the database server starts when the application starts. It's also an in-memory database, so there is no persistent storage of information across restarts of the application. This is not something you'd use in production, but perfect for a small demonstration like this one. All the classes in the model package will be used to store data loaded from the database. And these are just plain old Java objects. Finally, the publisher mapper interface defines signatures of all the DAO methods we want to create. Right now, this is just an empty interface. Let's annotate it so MyBatis can build us an implementation. The first thing to do is to add an @mapper annotation to register this class with MyBatis. And that's set there. The next step is to add an @select annotation that contains a SQL query we want to run on the database. This is using an explicit column name to Java property name mapping. But since the ID and name DB columns have the exact same name as a Java model property, we can drop the explicit alias mapping. Like so. Since we want all the columns in the publisher table to be returned, we can simplify this further using a wildcard. For the phone column, there isn't an exact match to a Java property, which means we need to keep the explicit alias mapping here. Let's see if all this works by calling the findAll method from a unit test. In this test, you can see we're making a call to a findAll method that we just set up. We're injecting a publisher mapper bean built by MyBatis that does all of the SQL execution for us behind the scenes. And here we're just going to print the results of our query that were returned in this publisher object. Let's go ahead and run this. As you can see, it's returned the values we stored in the database. I'm also printing the class name of the publisher mapper bean. You'll notice it's a proxy class, so it's something generated by MyBatis. Let's take a look at another mapper interface. In the book mapper interface, there's an example of how to pass in parameter values to a select statement. The MyBatis @param annotation is used to link parameters from the interface method to matching expressions in the select statement. Let's take a look at one more mapper interface example. If you enable Groovy compilation in your project and are using a Groovy interface for your mapper, then you can use the handy triple quote Groovy syntax for supplying a multi-line value to the @select annotation. This allows you to paste in large SQL queries right into your code, and vice versa, extract queries from your code and run them in a SQL client. Because of time constraints, we only cover the @select annotation here, but there are equivalent annotations for the SQL insert, update, and delete commands. Let's wrap up this presentation and review what we've learned. That demo concludes our presentation. To recap what we've learned, MyBatis links Java interface methods to SQL statements. MyBatis uses SQL directly. There is no generation of SQL like with some alternatives such as JPA. Result mapping is based off of existing SQL language constructs like aliases and wildcards, so there is no new mapping language to learn. We saw how we could build a simple DAO with just a few annotations. And finally, we saw how MyBatis and Groovy work particularly well for multi-line SQL statements. I hope you've enjoyed this brief introduction to MyBatis. Included here is a link to the code used in the demonstration and a link to some other useful resources. Thank you.